Welcome to our module on wiring basic control systems. For gas fitters, understanding electrical diagrams and control circuits is essential for both installation and troubleshooting. Let's dive into the different types of drawings and components you will encounter in the field.
We will start with pictorial diagrams. These are the easiest to understand because the components are drawn to look exactly like their real-life counterparts. They show the actual physical layout and often indicate wire colors. While great for beginners or instruction manuals, they can get a bit cluttered for complex systems.
Next, we have block and one-line diagrams. A block diagram acts like a flowchart, showing the logical sequence of events using simple boxes. A one-line diagram is similar, but uses standard electrical trade symbols instead of blocks. These do not show the return path for the circuit or the physical location of parts, but they are fantastic for illustrating the main components of a large distribution system.
When you actually need to wire a circuit or trace wires for troubleshooting, you will use a wiring diagram. Think of this as a map. It shows exactly how and where wires connect between devices. Wires are drawn horizontally and vertically for clarity, and a solid dot indicates where two crossing wires actually make an electrical connection. Finally, we have schematic diagrams, specifically ladder diagrams. These emphasize how a circuit works electrically rather than how it looks physically. The left side represents incoming voltage, the right side represents the loads, and the horizontal lines, or rungs, show the switches and connections. This is the go-to drawing for understanding the electrical logic of a system. Before we look at the appliance itself, we need to understand how power gets there. The branch circuit usually provides 110 volts and consists of three main parts: the circuit breaker at the panel, an appliance disconnect switch located near the unit for safety, and the junction box on the appliance where the final connections are made. At the start of that branch circuit is the circuit breaker. Its job is to protect the wiring and equipment from dangerous overcurrents or short circuits. Thermal breakers use a bimetal strip that heats up and bends to break the circuit during a mild overload, while magnetic breakers trip instantly during a massive surge like a short circuit. The gas code requires a manual disconnect switch near the appliance so you can safely cut the power during servicing. Always test this with a meter. Once power reaches the appliance, all 110-volt connections must be made inside a metal junction box to prevent short circuits and shock hazards. When you open an appliance and see a plate of spaghetti wiring, do not panic. Follow a systematic approach. First, identify the four main circuits: combustion safety, control, transformer, and fan. Second, locate the switches and loads for each. Finally, wire them one by one, starting with the highest voltage, like the 110-volt fan circuit, and working down to the millivoltage safety circuits. In more complex systems, you will encounter switches with more than two terminals. For example, an air pressure switch is a single-pole double-throw switch. It has a common terminal, a normally open terminal, and a normally closed terminal. Depending on how you wire it, the circuit can either close or open when the switch is pressurized. Another common multi-terminal device is the combination high limit and fan control. It houses a normally open switch to turn on the blower when the furnace heats up, and a normally closed limit switch that cuts power to the gas valve if the furnace overheats. A small metal jumper often connects the two, so they can share a single power source. Gas valves often look complicated because they have multiple terminals, but remember that the internal coil only needs two connections. The extra terminals and jumper wires are just there to act as a convenient connecting block for your thermostat, high-limit switches, and pilot generators. Finally, let's look at direct drive fan motors. These often come with multiple speed taps, like high, medium, and low. For a single speed setup, you just wire one tap and cap the rest. But if you need two speeds, say a low speed for continuous circulation and a high speed for heating, you can use a relay to automatically switch between the taps when the thermostat calls for heat. And that wraps up our look at basic control systems. Remember, mastering the different types of electrical drawings, understanding the branch circuit safety components, and following a systematic voltage-based approach to wiring will make troubleshooting any gas appliance safe and straightforward. Keep practicing with those schematic diagrams.